Hello friends, from today I will start the video from the CBSC Board Mathematics and the first chapter. Now this chapter is a fifth chapter from the CBSC textbook and the topic is complex number. Just I had uploaded the same topics from the Maharashtra State Board complex number. You can distinguish what type of the examples in these two videos. Now let us start, and this will help you in a preparation for the JEE examination. Now let us start. The chapter number 5 from the CBSC Board, complex number and quadratic equations. First we'll discuss on the complex numbers. Next, introduction. In earlier classes, we have studied linear equations in 1 and 2 variables and quadratic equation in 1 variable. Next, also we have seen that the equation x square plus 1 is equals to 0 has no real solution, as x square plus 1 is equals to 0 gives x square is equals to minus 1, and the square of every real number is a non-negative. So we need to extend the real numbers system to a larger system so that we can find the solution of the equation, this type of equation. X square is equals to minus 1. In fact, the main objective is to solve equation ax square plus bx plus c is equals to 0, where d is equals to b square minus 4ac. If the discriminant is less than 0, which is not possible when we solve the quadratic solution of the quadratic equation, which is not possible in the system of the real number. Complex numbers. Let us denote a root of minus 1 by the symbol I. Then we have I square is equals to minus 1. This means that I is a solution of equation x square plus 1 is equals to 0. A number of the form a plus ib, where a and b are real numbers, is defined to be a complex number. Next, for example, 2 plus I3 minus 1 plus I root 3, 1 plus I in bracket minus 1 upon 11 are complex numbers. The complex number z is equals to a plus ib. A is called the real part, denoted by a real part of z, and b is called imaginary part, and denoted by imaginary part of z of the complex number z. For example, if z is equals to 2 plus I5, then what is the real number? Real part here, 2 is the real part. And what is the imaginary part? That is, imaginary part is 5. Two complex number z1 is equals to a plus ib and z2 is equals to c plus id are equal if a is equals to c, their real parts are equal and imaginary parts are equal. That is, a is equals to c and b is equals to d. Next, example 1. Now see this here. If 4x plus I in bracket 3x minus 5 bracket complete is equals to 3 plus I in bracket minus 6, where x and y are real numbers. Then find the values of x and y. Solution. We have 4x plus I times in bracket 3x minus 5 is equals to 3 plus I times in bracket minus 6. Now equate the real and imaginary part from this equation. That is, 4x is equals to 3. That is, we get 4x is equals to 3. Equate the real part. And 3x minus y is equals to minus 6. And if we solve this, then you will get x is equals to 3 by 4. And y is equals to minus 33 by y is equals to 33 by 4. Next. Now the algebra of complex number means what? Addition, subtraction, multiplication and the division. How we can multiply, add and the division of the complex number. This explanation is here. Algebra of complex number. In this section we shall develop the algebra of complex numbers. First is addition of two complex numbers. Let z1 is equals to a plus ib and z2 is equals to c plus id be any two complex numbers. Then the sum z1 plus z2 is defined as follows. z1 plus z2 is equals to a plus c plus I times in bracket b plus d, which is again complex number. For example, 2 plus 3i plus minus 6 plus 5i, that is a 2 minus 6, that is a algebraic addition of these two numbers, real part, and the complex, that is a 3i plus 5i, that is a 3 plus 5, that is a 8i. Therefore, their addition is a minus 4 plus 8i. The addition of complex numbers satisfy the following properties. First is the closure law. The sum of the two complex number is again a complex number. This is the closure law. That is, a z1 plus z2 is a complex number. For all complex numbers, z1 and the z2. Next is a commutative law. For any two complex numbers, z1 and z2, z1 plus z2 is equals to z2 plus z1. Third one, the associative law. For any three complex numbers, z1, z2, z3, z1 plus z2 bracket complete plus z3 is equals to z1 plus in bracket z2 plus z3. Fourth one, this is the associative law. The existence of additive identity. If we add, then we get the original number. That is 0 plus I0 is a additive identity. There exists a complex number 0 plus I0 denoted as a 0 is called the additive identity or the zero complex number, such that for every complex number z plus 0, that is nothing but the z. The existence of additive inverse. To every complex number z is equals to a plus ib, we have the complex number minus a plus I times minus b denoted as minus z, called the additive inverse or the negation of z. We observe that z plus minus z is equals to 0, the additive identity. Now the difference of two complex numbers. Given any two complex numbers, z1 and z2, the difference z1 minus z2 is defined as follows. z1 minus z2 is equals to z1 plus in bracket minus z2. For example, 6 plus 3i minus in bracket 2 minus I, and that's equals to 6 plus 3i plus minus 2 plus in bracket minus 2 plus I. 6 plus 3i minus 2 minus I, and if we simplify it, that is a 6 minus 2, then you will get 4. 3i plus I, that is a 4i. And 2 minus I minus in bracket 6 plus 3i, and that's equals to again 2 minus I plus minus 6 minus 3i, and if we simplify it, then you will get 2 minus 6, that is a minus 4, minus I, and minus 3, that will become minus 4i. Next is a multiplication. Multiplication of two complex numbers. Let z1 is equals to a plus ib and z2 is equals to c plus id be any two complex numbers. Then the product z1 into z2 is defined as follows. z1 into z2 is equals to ac minus bd plus I times AC plus BC. For example, 3 plus 5i into 2 plus I6, or you can write 6i. Now the multiplication of the A into C. What is the C here? The C is a 2, A is a 3 and C is a 2 minus BD. B is 5 and D is a 6. 5 into 6. Then you will get the, by using this formula you can perform the calculation. That is a 2 into 3 into 2, 6 and minus 30 minus 24. This is the real part. What about the imaginary part? 3 into 6, 18 and plus 10, that is a 28i. The multiplication of complex numbers possesses the following properties which are the stated without the proof. Next, the closure law. The product of two complex numbers is again a complex number. The product z1 into z2 is a complex number for all complex numbers z1 and z2. Next, the commutative law. For any two complex numbers z1 and z2, z1 into z2 is equals to z2 into z1. This is a commutative law for the multiplication. And the associative law. For any three complex numbers z1, z2, z3, z1 into z2 bracket complete into z3 is equals to z1 in bracket z2 into z3. Fourth one, the existence of multiplicative identity means what? 5 into 1, that is equals to 5. That is, it is a multiplicative identity in regular algebra, algebraic numbers, real numbers, there exists the number 1 plus I0 denoted as 1 called the multiplicative identity such that z into 1 is equals to z for every complex number z. The existence of multiplicative inverse for every non-zero complex number z is equals to a plus ib or a plus bi, where a is not equals to 0 and b is not equals to 0, we have the complex number a upon a square plus b square plus I times minus b upon a square plus b square denoted by 1 upon z or z raised to minus 1, called the multiplicative inverse of z such that z1 into 1 upon z is equals to 1. The multiplicative identity the distributive law for any three complex numbers z1, z2, z3. See this here, z1 in bracket z2 plus z3 is equals to z1 into z2 plus z1 into z3. Next, z1 plus z2 bracket complete into z2. Sorry. Again see this here, in bracket z1 plus z2 bracket complete into z3, and that is nothing but z1 into z3 plus z2 into z3. Next, division of two complex numbers. Given any two complex number z1 and z2, where z2 is not equals to 0, the quotient z1 upon z2 is defined by z1 upon z2 is equals to z1 into 1 upon z2 . For example, z1 is equals to 6 plus 3i and z2 is equals to 2 minus I. Then z1 upon z2 is equals to 6 plus 3i into 1 upon 2 minus I. That is a 6 plus 3i, and if we multiply it's a conjugate part, that is a 2 plus I, then you will get by using this formula that we have learned in the previous slide, that is a 2 upon 2 square plus minus 1 bracket square plus I minus in bracket minus 1 upon 2 square plus minus 1 square, and then you will get that is a 6 plus 3i, 2 plus I, that's minus and minus, that will become plus, 2 square is a 4, minus 1 square is again 1, 4 plus 1 that is a 5, therefore it is a 2 plus I upon 5. Therefore you will get 1 by 5, 6 plus 3i into 2 plus I. That is if you take the multiplication, that is a 2 into, that's 6 into 2, that is a 12, 3i into I, that is a 3i square, which is a minus 3 plus I times 6 plus 6. Therefore you will get z1 upon z2 is equals to 1 by 5, 9 plus 12i. Power of I, we know that I cube is equals to I square into I, but I square is minus 1. Minus 1 into I, overall you will get minus I. Next is I raised to 4, means what? I square and bracket square. I square means what? Minus 1, it's a square, that is a 1. I raised to 5, I square and bracket square into I. and overall you will get I, 1 into I, that is I raised to 6, I square and bracket raised to 3, minus 1 bracket raised to 3 is minus 1. Also, we have I raised to minus 1 is equals to 1 upon I into I upon I. We will multiply numerator and denominator by I. Then what you will get? 1 into I is I into I is I square, but I square is minus 1, and therefore here is a minus 1. Again I will explain here. I raised to minus 1 means what? 1 upon I. Multiplied n and d by I. 1 into I is I into I is I square, but what is the value of I square is minus 1. And overall you will get minus I, and hence I raised to minus 1 is nothing but the minus I. I raised to minus 2, again it is written as 1 upon I square. And what is the value of I square? I square is a minus 1, and hence by mistake here there must be, see this here, I raised to minus 2 is equals to 1 upon I square is minus 1, and overall the value of I raised to minus 2 is minus 1. I raised to minus 3 is 1 upon I raised to 3, and it is written as I square into I, but I square is minus 1. Overall the value of 1 upon I raised to 3 is a 1 upon minus I. Multiplied n and d by again I. Then you will get I into I, that is I square minus I square, but I square is a minus 1. Overall that will become plus 1. Okay, 1 into I is a I here, and we get the value I raised to minus 3 is I raised to minus 4, and it is written as 1 upon I raised to 4. That is a 1 upon I raised to 4 means what? I square and bracket square. I square is minus 1. Minus 1 square is again plus 1. That is 1 upon 1. Therefore, I raised to minus 4 is 1. In general, for any integer k, I raised to 4k is equals to 1. I raised to 4k plus 1 is I raised to 4k plus 2, that I raised to 4k into I square, but I raised to 4k is 1, and I square is minus 1. 1 into minus 1 is again minus 1. I raised to 4k plus 3, that is I raised to 4k is again 1, but I cube means what? I square into I, but I square is a minus 1. Minus 1 into I, that is you will get minus I. The square root of a negative real number, that is a, note that I square is minus 1, minus 1 minus I square is equals to I square, and that is equals to minus 1. Therefore, the square root of minus 1, the square root of minus 1, if you take the square root of minus 1, that is 1 is I, and another is a minus I. However, by the symbol root of minus 1, we would mean I only. That is, the root of minus 1 is also always called the I. Now we can see that I and minus I both are the solutions of the equation x square plus 1 is equals to 0, or x square is equals to minus 1. Similarly, root 3 I bracket square is equals to root 3 square means what? 3. I square is minus 1, and therefore root 3 I bracket square is equals to minus 3. minus root 3i bracket square is equals to minus root 3 square and I square, and therefore minus root 3 square is again 3, but I square is minus 1. Overall you will get minus 3. Therefore the square root of minus 3 are root 3i and minus root 3i. We get the two square root. Again, this symbol root of minus 3 into root of minus 3 is meant to represent root 3 into I, because minus 3 means what? 3 into minus 1, and minus 1 means what? I square, and what is the square root of I square? Is I. Therefore, a root of minus 3 is root 3 into I only. Root of minus 3 is equals to root 3 into I. Generally, a is a positive real number. Again, I will repeat here. Generally, if a is a positive real number, a root of minus a is equals to root a into root of minus 1. We can write this. Therefore, root of minus a is equals to root a into I. We already know that is a root a into root b is equals to root of ab for all positive real number a and b. This result also holds true when either a is a positive and b is negative, or a is negative and b is a positive. What if a is a negative and b is a negative? Then what will happen? Let us examine. Note that I square is equals to minus 1. Okay, I square is equals to minus 1. But again it can be written as, that is a I into I. But I means what? Root of minus 1. And again this is a root of minus 1. If you take in the same root sign, then you will get, by using the laws of indices, we can write this. That is minus 1 into minus 1. That will become plus 1. By using the laws of indices. Therefore, a root of 1. And what is the root of 1? Is again 1, which is contradiction to the fact that I square is equals to minus 1. Therefore, root a into root b is not equals to root of ab if both a and b are negative real numbers. Further, if any of a and b is 0, then clearly root a into root b is equals to root of ab, and that's equals to 0. Identities. We prove the following identity. The first is z1 plus z2 bracket complete bracket square is equals to z1 square plus z2 square plus 2 times z1 into z2 for all complex numbers z1 and z2. Next is the z1 plus z2 bracket square is equals to z1 plus z2 first bracket and second bracket z1 plus z2. If you take their multiplication, then you get z1 plus z2 into z1 and z1 plus z2 into this z2. Then you will get here z1 plus z2 bracket square is equals to z1 square plus z2 into z1 plus z1 into z2 plus z2 square. And here you will get z1 square plus z1 into z2 plus z1 into z2 plus z2 square, that is using the distributive law, and hence z1 plus z2 bracket square is equals to z1 square plus 2 times. Instead of here is the distributive law, I must write here the commutative law, that is a z1 square plus 2 times z1 into z2 plus z2 square. By using the commutative, already it is written here. This is correct one. I have written here commutative law for the multiplication. Similarly, we can prove the following identities. First is z1 minus z2 bracket square is equals to z1 square minus 2 times z1 into z2 plus z2 square. Second, z1 plus z2 bracket cube is equals to z1 cube plus 3 times z1 square into z2 plus 3 times z1 into z2 square plus z2 cube. Next is z1 minus z2 bracket cube is equals to z1 cube minus 3 times z1 square into z2 plus 3 times z1 into z2 square minus z2 cube. And fourth one, z1 square minus z2 square, that is equals to z1 plus z2 in the first bracket and second bracket z1 minus z2. In fact, many other identities which are true for all real numbers can be proved to be true for all complex numbers. Now, examples. Express the following in the form a plus ib. The first is minus 5i into 1 upon 8i. Normal multiplication is here. That is minus 5i into 1 upon 8i. 5 minus 5 by 8. I into I is I square. I square is minus 1. And overall you will get 5 by 8. Therefore, minus 5i into 1 upon 8i is equals to 5 by 8 plus I 0. Next is a second, minus I into 2i into minus 1 upon 8 into I bracket cube. Minus I into 2i minus 1 by 8i bracket cube, and that is equals to 2 into 1 upon 8 into 8 into 8. And what about the I raised to 3, and here is I into I square. Overall the power of I is 5. That is 1 upon 256. I raised to 5 means what? I raised to 5 means what? I square bracket square into I. That I raised to 4 into I. But I square is minus 1. Minus 1 square is again 1. 1 into I is I. And therefore, here you will get that is 1 upon 256 into I. Now next example. Express in bracket 5 minus 3i bracket cube in the form a plus ib. Now we'll expand by using the formula a minus b bracket cube. 5 cube minus 3 into 5 square into 3i plus 3 into 5 into 3i bracket square minus 3i bracket cube. Therefore 5 cube means what? 125. Next is a Next simplification is a 225i, and next is a minus 135. That is, here is I square is minus 1. Overall you will get minus term there, therefore it is a minus. Here is a 9. Okay, 9 into again this 3 into 5. And hence you will get the simplification of this 125 and minus 135, minus 10 and minus 225i minus 27i. Overall you will get minus 198i. Normal simplification is here. Therefore a plus ib is equals to minus 10 minus 198i. Next example. Express minus root 3 plus in root of minus 2 into in bracket 2 into root 3 minus I in the form of a plus ib. That's the solution. Normal multiplication is here. Minus root 3 plus root of minus 2 bracket complete. In next bracket 2 root 3 minus I is equals to minus root 3 plus root 2i bracket complete 2 root 3 minus I. And if you simplify this, then what is the root 3 into root 3? That is a 3. 3 into 2, that will become 6. Next is a minus root 3 and minus I, that is a root 3i. And what about the multiplication of these two? That is a 2. Root 2 into root 3, that is a root 6i. And the last is a minus, that is a root 2i into minus I. Then overall you will get minus root 2i square. Therefore a plus ib is equals to minus 6. If you simplify this, then you will get minus 6 plus root 2 plus root 3 in bracket 1 plus 2 root 2 bracket complete into I. The modulus and conjugate of a complex number. Let z is equals to a plus ib be a complex number. Then the modulus of z denoted by mod of z is defined to be the non-negative real number, that is the root of a square plus b square, that is the mod of z is equals to root of a square plus b square, and the conjugate of z denoted, that is a z bar, is a complex number and which is a minus ib. Therefore z bar is equals to a minus ib. This is the conjugate of the z. What is the z is equals to? Z is equals to a plus ib. Therefore it's a conjugate, that is the z bar is equals to a minus ib. For example, mod of 3 plus I is equals to in root of 3 square plus 1 square, that is a 9 plus 1, that is a root of 10. 2 minus 5i is equals to root of 2 square plus minus 5 bracket square, and that is a 2 square is a 4 and 25, that is a root of 29. And 3 plus I bar, that is it's a conjugate 3 minus I, that is the conjugate of 2 minus 5i, 2 plus 5i, conjugate of minus 3i minus 5, change the sign of this imaginary part only, that is a 3i minus 5. Next is a conjugate of 3 plus I is a 3 minus I. Conjugate of 2 minus 5i is equals to 2 plus 5i. Change the sign of only the imaginary part. That is the conjugate of minus 3i minus 5. That is a 3i minus 5. Observe that the multiplicative inverse of non-zero complex number z is given by z raised to minus 1 is equals to 1 upon a plus ib, as z is equals to, here the z is equals to a plus ib. Next, and their simplification multiplied it with its conjugate, and this is the formula. If we multiplied numerator and denominator by a minus ib, and if we simplify, then you will get a square plus b square, and that is a upon a square plus b square plus I into minus b upon a square plus b square, and overall you will get a minus ib upon a square plus b square, and that is equals to z bar upon, that is a mod of z and it's a square, or z into z bar is equals to mod of z square. Furthermore, the following results can easily be derived. Any two complex numbers z1 and z2, we have mod of z1 into z2 is equals to mod of z1 into mod of z2. Second is z1 upon z2 is equals to mod of z1 upon mod of z2, provided that z mod of z2 is not equals to 0. z1 into z2 bar is equals to z1 bar into z2 bar. Next is a z1 plus or minus z2 bar is equals to z1 bar plus or minus z2 bar, and the z1 upon z2 bar is equals to z1 bar upon z2 bar, provided that is a z2 is not equals to 0. Example, find multiplicative inverse of 2 minus 3i, that is a z is equals to 2 minus 3i, z bar is equals to 2 plus 3i, and mod of z square is equals to 2 square plus minus 3 bracket square, that is equals to 13. Therefore, the multiplicative inverse of 2 minus 3i is given by z raised to minus 1 is equals to z bar upon mod of z square, that is equals to 2 plus 3 upon 13, that is a 2 minus 13 plus 3 upon 39. Now the above working can be reproduced in the following manner that we have done here. Also, that is a z raised to minus 1 is equals to 1 upon 2 minus 3i. Next is a 2 plus 3i upon 2 minus 3i into 2 plus 3i, that is a multiplied, it's a numerator and denominator by 2 plus 3i. Then you will get 2 plus 3i upon 2 square minus 3i bracket square, that is a 2 plus 3i, and here you will get 13, 2 square, and next is a 3i square means what, 9i square, but I square is minus 1, and that minus and minus will become plus, 9 plus 4, that is a 13. Therefore, z raised to minus 1 is equals to 2 upon 13 plus 3 upon 39. Next example, express the following in the form a plus ib. The first is 5 plus root 2i upon 1 minus root 2i. Solution, we have 5 plus root 2i upon 1 minus root 2i, 5 plus root 2i upon 1 minus root 2i multiplied and by its a conjugate 1 plus root 2i, that is a 5 plus 1 minute. If we take the multiplication, 5 into 1 is 5, 5 into root 2i, that is a 5 root 2i, root 2i into 1, that is a root 2i, and root 2i into root 2i, that is a I square is a minus 1, root 2 into root 2, 2, that is a minus 2. And simplify this, that is 5 minus 2, 3, and addition of these two, that is a 6 root 2i. 1 minus root 2i bracket square means what? 2i square. I square is a minus 1, and that minus will become plus. That is 1 plus 2, that is a 3. Therefore take 3 as a common, and then you will get 5 plus root 2i upon 1 minus root 2i is equals to 3 get cancelled, and overall you will get 1 plus 2 root 2i. Second example, I raised to minus 35 is equals to 1 upon 35, 1 upon I raised to 35, and it can be written as I square and bracket raised to 13 into I, and overall you will get I raised to 35. But what is I square? I square is minus 1. Minus 1 raised to 17. Overall that will become minus 1. Minus I. Again multiplied n and d by. Here you will get minus 1. Minus 1 into I is a minus I. Multiplied numerator and denominator by I. 1 into I is I. And I into I is I square minus I square. And therefore here you will get I raised to minus 35. I square is minus 1, and that is minus, and minus will become plus. Therefore I raised to minus 35 is I. Now we'll start the exercise 5.1. Express each of complex number given in the exercise 1 to 10 in the form a plus ib. First, 5i into minus 3 by 5i. Here the multiplication, this 5 get cancelled. Okay, minus 5 into 3 by 5 I into I. 5 get cancelled. Minus 3 into I square is minus 1. And overall, you will get here minus 3i square that is equals to 3, and we will express in this form a plus ib. Imaginary part is 0, that is a 3 plus I0, that is equals to a plus ib. Next example, I raised to 9, I raised to 19. Now we write here I raised to 9 means what? I raised to 4 into 2 plus 1, and here is a 19 means what? I raised to 4 into 4 plus 3. I raised to 4 bracket square into I here. This 1 means what? I raised to 1 means what? I raised to 4 and bracket raised to 4 into I cube. And here you will I raised to 4 means what? 1. 1 square means again 1. 1 into I. Overall you will get I here. And the next is again here I raised to 4 is 1. 1 raised to 4 is again I 1. I cube means what? Minus I. And here is a I plus minus I. Overall you will get G. That is equals to 0 is equals to A plus IB, where the value of A is 0 and B is also 0. Next example, I raised to minus 39. It can be written as I raised to minus 4 into 9 minus 3. That I raised to 4 into that is raised to minus 9 into I raised to minus 3. Here you will get 1 raised to minus 9, I raised to minus 3, I raised to 4 is 1, and overall you will get here the I raised to minus 9 is again 1, and I raised to minus 3 means what? 1 upon I raised to 3 by using the law of indices. But again I cube means what? Minus I. Therefore it is a 1 upon minus I. Again we will multiply n and d by I. And here I into I square. I square is minus 1, and this minus 1 that will become plus. Overall you will get I. See this here. That is overall you will get I. Therefore we can express this 0 plus I, that is equals to 0 plus I is equals to A plus IB. Next example. 3 in bracket 7 plus I7 plus I in bracket 7 plus I7. Normal simplification is here. 3 into 7 plus I7 bracket complete. I into in bracket 7 plus I7. Normal multiplication is here. 7 into 3, 21. 7 into 3 into 7, that is a 21. 3 into 7i, that is equals to 21i. I into 7 is 7i. I into 7i is a 7i square. Here is a 21, 28i, and I square is again minus 1. Okay, therefore overall you will get minus 7. That is a 21 minus 7 is a 14. 14 plus 28i. And that is equals to a plus ib. Therefore, a plus ib is equals to 14 plus 28i. Next is in bracket 1 minus I minus bracket complete minus in bracket minus 1 plus I6. Normal simplification is here. Open the bracket 1 minus I. If you open the bracket, you will get plus 1 minus 6i. 1 plus 1 2. Minus I minus 6 minus 7i, and you will get 2 minus 7i, that is equals to a plus ib. Next example, 1 upon 5 plus I into 2 by 5 in first bracket minus next bracket 4 plus I into 5 by 2. Now simplify this. Normal simplification is here. 1 by 5 plus I times 2 by 5 minus in bracket 4 plus I into 5 by 2 bracket complete 1 by 5 plus 2 by 5i minus 4 minus 5 by 2i. Open the bracket. If you open the bracket, sign will change. You will get minus 4 minus 5 by 2i. Now collect the real part and imaginary part. Algebraic addition is there. That is 1 by 5 minus 4 plus I times 2 by 5 minus 5 by 2. And overall you will get minus 19 by 5 plus I times minus 21 by 10. And hence you will get here the answer minus 19 by 5 plus 30 minus 21 upon 10 I, that is equals to a plus ib. Okay, next example. In bracket, square bracket, and then next rounded bracket 1 by 3 plus I times 7 by 3 bracket complete plus 4 in bracket 1 plus I into 1 by 3 bracket complete minus in next bracket minus 4 by 3 plus I. Now simplify this. 1 by 3 plus I into 7 by 3 bracket complete plus 4 plus I into 1 by 3 bracket complete minus in bracket minus 4 by 3 plus I. If you simplify this, then you will get 1 by 3 plus 7 by 3i plus 4 plus 1 by 3i, and next is by using this minus sign, the sign will change. That is minus 4 by 3 will become plus 4 by 3 plus I will become minus I. Now collect the real part and imaginary part. Then you will get 1 by 3 plus 4 plus 4 by 3 plus I times, what is here, 7 by 3, 1 by 3 minus 1, and then simplify it. You will get 17 by 3 plus I times 5 by 3, that is equals to a plus ib, and therefore a plus ib is equals to 17 by 3 plus I times 5 by 3. Get the example. In next bracket 1 minus I bracket raised to 4, and therefore the solution is as bracket raised to 4, we will simplify 1 minus I bracket square, and it's a square bracket, and it's again bracket square by using the law of indices. Now expand this. A minus b bracket square, that is 1 square plus I square minus 2i bracket square. I square is minus 1, and plus 1 and minus 1 get cancelled. You will get minus 2i bracket square. Okay, you will get minus 2i bracket square, and that is a minus 2i into minus 2i, that will become 4i square. I square is minus 1 minus 4. Therefore a plus ib is equals to minus 4 plus 0i. Next example, 1 by 3 plus 3i bracket cube. Therefore, the solution 1 by 3 plus 3i bracket cube, that is 1 by 3. A plus b bracket cube, 1 by 3 bracket cube plus 3i bracket cube plus 3 into, that is a, b in bracket a plus b. You can expand like this also. That is a plus b bracket cube means what? A cube plus b cube plus 3ab in bracket a plus b by using this formula. What is that formula? A plus b bracket cube is equals to a cube plus b cube plus 3 times a into b in bracket a plus b. This is also formula. Now simply normal simplification is a 1 by 3 bracket cube means what? 1 upon 27 plus 3i bracket cube means what? 27i cube. Next is a 3 get cancel, you will get 3i in bracket 1 by 3 plus 3i. Next simplification 1 upon 27. I cube means what? Minus I. Now 3 get cancel, you will get I. 3i into 3i, 9i square. I cube is minus I. And therefore you will get 1 upon 27 minus 27i plus I minus 9. I square is minus 1. And if you simplify it, then you will get collect the real terms and imaginary terms. 1 upon 27 minus 9 plus I times minus 27 plus 1. And here you will get the minus 242 upon 27 minus 26i, and that is equals to a plus ib. This is the required form. Therefore, a plus ib is equals to minus 242 upon 27 minus 26i. Next example, minus 2 minus 1 by 3 I bracket cube. And therefore, the solution, here we will apply the formula minus 1 cube. Okay. Take the minus sign common from this, then you will get minus 1 and it's a cube. Next is a 2 plus 1 by 3 bracket cube. We have taken the minus 1 common from these two terms. But here is a bracket cube and that's why here is a minus 1 cube. Now simplify this. Minus 1 cube means what? Minus 1. Now 2 plus 1 by 3 I bracket cube means what again? A cube plus b cube plus 3 times a into b in bracket a plus b. Normal formula 2 raised to 3 is 8. 1 by 3 bracket cube means what? I cube upon 27 and if 3 get cancelled you will get 2i in bracket 2 plus 1 upon I upon 3. Again simplification minus 8. I cube means what again? Minus I upon 27 plus 4i. Next is a 2i square. I square is minus 1, that is a minus 2 by 3. And overall you will get minus in bracket 8 minus I upon 27 plus 4i minus 2 upon 3. Okay. And if you simplify this, then you will get 22 upon 3. That is 8 minus 2 by 3 means what? 22 upon 3. And minus I upon 27 plus 4i. Overall you will get 107i upon 27. Therefore, a plus ib is equals to minus 22 upon 3 minus 107 upon 27i. Next is a find the multiplicative inverse of each of complex numbers. 4 minus 3i. The solution is answer. Z is equals to 4 minus 3i. Then Z bar is equals to 3 plus 4i and mod of Z square is equals to 4 square plus minus 3 bracket square, that is equals to 16 plus 9, that is equals to 25. Therefore, the multiplicative inverse of 4 minus 3i is given by z raised to minus 1 is equals to z bar upon mod of z square, that equals to 4 plus 3i upon 25. This is the multiplicative inverse. 4 upon 25 plus 3 upon 25i. Root 5 plus 3i Next example, root 5 plus 3i. The solution is, let z is equals to root 5 plus 3i. Therefore, the z bar is equals to root 5 minus 3i. It's a conjugate, and mod of z square is equals to root 5 square plus 3 square. 5 plus 9, that is equals to 14. And therefore, the multiplicative inverse of root 5 plus 3i is given by z raised to minus 1, z bar upon mod of z bracket square, and that is a root 5 minus 3i upon 14. Therefore, z raised to minus 1 is equals to root 5 upon 14 minus 3i upon 14. Next, minus I, and let z is equals to minus I, then z bar is equals to I, mod of z square is equals to 1 square, that is equals to 1. But minus I square is again 1, and it's a square. Therefore, the multiplicative inverse of minus I is given by z raised to minus 1 is equals to z bar upon mod of z square, I upon 1, that is z raised to minus 1 is equals to I. Next is express the following expression in the form of a plus ib, that in bracket 3 plus I root 5, in second bracket 3 minus I root 5 upon, in bracket 3 plus root 2i minus root 3 minus I root 2 in this second bracket. Normal simplification here. See this here. 3 plus I root 5 into 3 minus I root 5 upon root 3 plus root 2i minus in bracket root 3 minus I root 2. Here is the simplification. Again, step is repeated here. A plus b, a minus b means what? A square minus b square. 3 square minus I root 5 bracket square, and normal simplification is open the bracket. You let minus root 3 plus root 3 get cancelled. Root 2i plus root 2i, that is a 2 times root 2i. Okay, next. That is a 9 minus 5i brackets I square. 2 root 2i, and here is a simplification. That I square is minus 1. Minus 5 into minus 1 is a, therefore 9 plus 5, 2 root 2i. Again multiply numerator and denominator by I. Then here you will get 14i upon 2 root 2 into I square. I square is minus 1. 14i 2 root 2 in bracket minus 1. And if you simplify it, then you will get minus 7i upon root 2. Multiply n by root 2. Then this root 2 will become 2. That is a minus 7 root 2i upon 2. Therefore, a plus ib is equals to 0 plus minus 7 root 2i upon 2. And in this way, we have completed the first exercise. This is my first video for all the CBSC student, and this will also help to the Maharashtra State Board for their preparation for the JEE examination. I will see you in the next video. Till then, goodbye.